Now that we are done using this method, we are going now to use the washer's method in finding the volume of solid generated by a revolution. Uh, let's take a look with this graph. We say that it is a washers because when we graph the function, we can form a circle here, but when we have another function which is linear function that which shows the graph in the line in the graph, it will form another circle here. That's why we call this a washer or washer's method. In order to find the volume using washer's method, we use the formula. The volume is equal to the integration of the square of the outer radius minus the square of the inner radius dx from A to B. Let's say, for example, the region enclosed by the curves y equals x and y equals x squared is rotated about the x-axis. Find the volume of the resulting solid. Our solution, first we will graph the function. It will look like this. This is the graph of the linear function y equals x, and this is the graph of the quadratic function y equals x squared. The radius, in order to find the outer radius, r sub outer radius equals top minus bottom is equal to x minus 0, that is here in the graph, then equals x. The inner radius will become top minus bottom equals x squared minus 0 equals x squared. To find its volume, we will substitute the given value or the given information to the formula. Our volume will become pi times the integration of the square of the outer radius minus the square of the inner radius dx from A to B will become pi times the integration of x squared minus x squared raised to 2 dx from 0 to 1. It will become pi times the integration of x squared minus x to the 4th dx from 0 to 1. Applying linearity, when we integrate this function, it will become pi times the x minus x raised to 3 over 3 minus x raised to 5 over 5 from 0 to 1. When we evaluate this function, it will become 2 over 15 times pi, or approximately equal to 0 and 419 thousandths cubic unit. For us to be able to better understand the topic using Wasser's method, let's solve another example. Find the volume generated by the curves y equals x and y equals x squared rotated about the line x equals -1. As you can see, it is the same with example number 1. But then, this one will rotate about the line x equals -1. Since we are solving involving the line x about x equals -1, we will interchange the variable. We will solve this function in terms of y. That's why y equals x squared become x equals the square root of y, and y equals x will become x equals y. To find the radius, the outer radius, we will use the formula right minus left, or the square root of y minus -1 will become the square root of y plus 1. And the inner radius will become y minus -1, and the result is y plus 1. To find the volume, we will use the formula. Volume is equal to pi times the integration of the square of the outer radius minus the square of the inner radius dy. Since we are solving in terms of y, we use the symbol dy, or the derivative of y, from A to B, equals pi times the integration of the square root of y plus 1 raised to 2 minus y plus 1 raised to 2 dy from 0 to 1. When we evaluate this equation, or this function, it will become pi times 1/2, or approximately equal to 1.571 cubic unit. And that ends my presentation. Thank you, sir.